Okay guys, another what I hope will be a quick one. This is I've taken the top cover of the engine off. This is a 1999 Mitsubishi Pajero with a 3.5 liter GDi engine. The customer complaint is the vehicle has hard start issues. It does start, especially when cold. When it gets warm, when the engine gets warm, it runs very poorly, and even sometimes refuses to start. Like right now, it won't crank, but I cranked it earlier and warmed the engine, and then because I wanted to do wiring checks, I switched the engine off. I'm cranking it now, but it's not starting. But I know that's because the fuel is flooded in the cylinders. So when it is left for a long time, I think the fuel cools on the cylinder walls, and the mixture is good enough for it to start again. Anyway, I looked for fault codes. I scanned for fault codes. There was one for this motor, which I think was created when someone unplugged the motor, and there were 3 codes. There was another one, I forget which it was, but I kept the information. I'll tell you, I'll put captions in the video when I'm editing it to tell you what the code was, what the third code was. But the most important code was the P0191, which is related to the fuel rail pressure sensor signal. Indeed, the signal was bad. That is with the key on. You are seeing only okay, it's now going up to, no, it's because I removed the ground. I'm going to reconnect the ground here. So I've reconnected the ground, and you can see there is only 0.14 volts. Now in the repair information I have from my repair source, says the minimum on this sensor with the key on should be 0.3 volts. So the sensor looks bad, and to be sure there is nothing else. The problem, like the wire to the computer from this sensor, the signal line and the computer are good. I'm looking at data here. It's very bright. It's a very sunny day today. Wondering if you can see that. Wondering if you can see. Fuel. I hope you can see the fuel pressure sensor. It's reading minus 0.8 volts. Now I'm going to use the test light connected to ground. This is my test light, and remove and tap it on the signal wire, and you can see it goes to minus 1 MPa. I've disconnected it, 0.8, connected it, touched it on the signal line, that is minus 1, disconnected it, 0.8. All I'm doing is right here. Right here, I'm connecting it and disconnecting it like that. I'm tapping it on and off like that, and you can see the changes here. Grounded, not grounded, grounded, not grounded. So for sure I'm on the signal line with the computer, and that's all the proof I need. This car needs a new fuel pressure sensor. Thank you. Okay, so this is where this case study started getting a little bit long and more complex than just the sensor. After the sensor fuel pressure sensor issue had been rectified, the vehicle would start, run and idle kind of okay, And then when we took it out on a test drive, there were really bad mechanical sounds coming out of the engine. Not only that, it lacked power severely, especially going uphill, and it was misfiring. Even it would misfire, not so badly at idle, but misfire even more once the engine was loaded, once it was being driven. So at that point, I started to investigate. My first stop was to check the ignition coils. So this is a ramp of ignition coil current. There are 6 ignition coils, and you can see there was nothing wrong with them. This is 6 ignition coils repeated. That's the current. There's nothing wrong. They don't look like they have anything wrong with them. And I zoomed further into one current coil current ramp, and from what I could see based on this image here, it was normal. There was nothing like a short. I would expect if there was a short, I would expect a jump here. There was nothing like that. Looked like it was ramping up well and discharging normally. So then the last year coil injector parade, but now I moved on to the injectors. This vehicle has a GDi engine, meaning direct injection. So the injectors carry more current. So this is a parade of all the injectors initially. 1, 2, 3, 1, 2, 3, 4. If this was 1, by the way, the firing order for this engine is 1, 2, 3, 4, 5, 6. Very easy. And the firing, if this was 1, for example, injector 1, this could be 2, 3, 4, 5, 6, and then it repeats 1, 2, 3, 4, and so on. So when you parade them like this, you can very quickly see that none of them has an issue. So I focused on 1 at a time, and you can see this is a very good pick and hold design. The current is looking very much like a good pick and hold design. So I couldn't pick any issue with the fueling. I couldn't find an issue earlier, like I said, with the ignition spark. So I moved on to, this is still injector current profiling. So I moved on to timing. This is still injector current. I was just taking more and more shots. Now here I came to ignition timing, because remember I had an engine that was misfiring, so I needed to rule out ignition, spark ignition, and rather ignition spark. I needed to rule out injectors, and I needed to rule out ignition timing, and then I would only be left with mechanical issues on the engine to do with compression. Anyway, here when I profiled the ignition timing is spot on, but you can see it is spot on. This is the injector current was inverted. This is when the event would start. For example, let me use this one. This is when the ignition event would start. Current would run up high like that, and then this is where the computer actually removes the ground from the coil, and you get the spark happening right at top dead center for all the cylinders. I didn't need to do it for all the cylinders, just one is enough, but in this case, because the wire I was using could show me the current for all the coils at the same time. So that's why you see, and this is these are the compression. This is current from the starter motor, so you can see even the relative compression is shown. And I don't know if you can pick it very well, but you can see this cylinder and this one have the highest compression compared to the others, and they are repeated here. And I think from what we shall see later, I think this is cylinder 2 and this is cylinder 4, because they turned out to have the highest compression, and this would be cylinder 1, and so on. So the ignition timing was spot on, but look, when you look at these relative compression traces, you can see you have a cylinder here which has high compression, then one with low, then another with high compression, and then it is repeated here. High compression, higher compression, okay, relatively higher compression here and here compared to all the others. So that alone is already showing me that there are mechanical issues with this engine. This is when I started now to begin suspecting and focusing on mechanical issues. I, of course, had already had the bad sound coming from the engine, especially when it went into speeds higher than 2000 RPM. There was a loud tapping noise, like something like that. You'd actually, if you are driving it, you'd when you heard it, you just take your foot off the pedal. There was something definitely wrong with this engine at this point, which I couldn't see before when I was, just looking out for the fuel pressure issues at idle. Anyway, so let's move on to what I did next to confirm that there are compression issues with the cylinders, because we needed this to get the customer to make a decision on whether we now open the engine up for mechanical repairs or checks or something like that or not. But this was a simple, quick test to point me firmly in the direction of mechanical issues on the engine. I could hear the sound, but what if I couldn't? What if I couldn't hear any mechanical sound? And most of the cases are usually like that. You don't hear anything mechanically wrong with it, but you can see it from the relative compression quick test. Check it out. 140. Kale kuba naye okuba olinyeeko. Check it out. That's 140. Kale piga. Check it out. Kale kuba. Kale kuba. Kera ate eri waasi 12.